Some proposals impact upon areas with unusual features or features that require non-standard survey methods or timing. If the EPA requires additional project-specific work, the environmental scoping document that's part of the assessment process may highlight this and require specific methodology to address the features. An example of this is sampling in keen pod communities across the zones of inundation on the edges of salt lakes. In this case, a specialised methodology is required because of the difficulties of identification for many of the species, because of speciation between those zones of inundation, and due to the different timing required to standard flora surveys to ensure that the fruits and flowers that are required for identification are actually collected. So what the EPA looks for in a flora and vegetation survey and report, they look for a contemporary desktop study used to guide survey method and that identifies potential significant flora and vegetation. They look for the accuracy and consistency of information. If there are mistakes and inaccuracies, it reduces confidence in the survey. So make sure the numbers in tables add up. Make sure that different parts of the report don't directly contradict each other, and check that species names are correct. The EPA is looking for survey effort and methods that are appropriate for the region, and in particular survey timing that is appropriate for the region. They're also looking for sufficient sampling sites. Sampling sites are needed both inside and outside the area of impact to provide the context for the proposal and confidence about the significance of the impacts. Also, if statements are made about significant flora and vegetation, for example, this vegetation unit is widespread outside of the study area, these statements need to be supported by evidence. The EPA also looks at qualifications and experience of botanists. It is essential that a survey is led by a botanist with knowledge and experience of the flora and vegetation of the bioregion to be surveyed. They should have at least 5 years experience in botanical survey in the bioregion. The experienced botanist should lead the survey from beginning to end in the field, supervising and training less experienced team members and checking their plant identifications. There are some reports that claim extensive experience, but then when you read the details, the experienced botanist was in an office in Perth, acting as a project manager, and did not actually lead the surveys. So, although a good survey depends on what you do on the ground, there are some attributes that come up that give us an indication that a survey is likely to be thorough. So obviously being consistent with guidance is one. Rescoring the same quadrats in a second season or a second year provides confidence in a robust analysis, as does incorporating quadrat data from adjacent projects, previous surveys and regional work into the floristic analyses. Where a consultant doesn't have multivariate analysis skills in-house, obtaining specialist technical assistance demonstrates that they've got a consistent to the methodology and guidance. Another indicator of a conscientious survey is that specimens of significant species have been vouchered and threatened and priority flora report forms have been filled out and submitted to DVCA. So that's for the surveys. Good reports have a detailed limitation section. This is actually usually pretty well done in most of the reports that we see. They're detailed, they provide an opportunity for the consultant to indicate if they think further survey work is required, or to inform of the challenges that there may have been in collecting the information and that may need to be taken into account when considering the adequacy of the survey. Where it is provided thoroughly, a detailed methodology for targeted surveys, such as maps, the habitat that were targeted for the surveys, GPS tracks of the staff who were doing the survey, and so on, can actually provide considerable confidence to the EPA about the adequacy of that survey effort. Similarly, species accumulation curves are often included and are a good way of demonstrating the adequacy of the survey effort as far as flora inventory is concerned. Most survey reports cover significant vegetation really well. For example, identifying riparian and groundwater dependent vegetation and restricted or highly cleared vegetation units. Survey reports often highlight important issues for consideration that may not be obvious from just reading the survey results, but that should be addressed in management. For example, one report identified the presence of a riparian area in the arid zone that was free from bucklegrass, which is quite a rarity. This allowed specific management conditions to be placed on the proposal to prevent buffer grass incursion as a result of the proposal. So the main areas for improvement, these areas arise regularly in survey reports. Survey effort and timing, addressing significant flora and vegetation beyond those that are listed as threatened or priority. The process of floristic analysis, vegetation description and mapping, and I'll cover each of these issues in the following slides with some examples. So, survey timing and effort. In relation to timing, surveys can be done in the wrong season, be done in a poor season, or be done in too few seasons. This is usually discussed quite well in the limitations, but needs to be addressed and not just acknowledged. Ideally, timing issues would be addressed through further survey. But if that's not possible, nearby surveys or professional experience can inform results. There are often insufficient quadrats per vegetation unit. The technical guidance specifies a minimum of 3 required per vegetation unit, with more in larger vegetation units or those with multiple occurrences. I will discuss this actually on a subsequent slide. And targeted flora surveys are often insufficient. Apart from listed species identified through desktop studies, significant species are generally not recognised as significant until after the specimens from initial quadrats have been identified. A single record from a quadrat with no information on extent is not sufficient to inform impact assessment. Looking around while walking between quadrats is not a targeted flora survey. Appropriate habitat should be targeted and searched. If previous records identified from the desktop studies are not relocated, that should actually be noted in the survey report. A population census should be undertaken and the extent of the population should be mapped to allow for impact assessment. So, significant flora and vegetation. Significant flora is not restricted to species listed as threatened or priority. It includes range extensions, potentially new taxa, locally endemic species and others. Nor is significant vegetation restricted to threatened and priority ecological communities. It includes locally restricted communities, highly cleared communities, vegetation with a role as a refuge and others. The significant flora and vegetation are defined in both the environmental factor guideline and they're on page 29 to 30 of the technical guidance as well. Although generally fairly good on significant vegetation, frequently survey reports only address flora listed as priority or threatened. The locations of all significant species and vegetation should be mapped, and depending on risk, a targeted survey might be required to determine the extent of the population or occurrence to inform impact assessment. Significant flora and vegetation needs to be mapped across the entire study area, even if it seems that they're distant from the proposal and the impacts, as footprints often change between survey and assessment, and there can be many years that pass, and then you end up with areas that haven't been mapped for significant flora. Another key issue is the vouchering of significant flora specimens. Although it is a requirement of the collecting licence, there is often no evidence that specimens of significant flora have been lodged at herbarium. This is particularly important for range extensions and priority flora species to improve the understanding of the true distribution and frequency of the species. It is also important for taxonomically uncertain species. Either herbarium accession numbers or collection details of specimens submitted for vouchering should be provided as an appendix to the flora and vegetation survey report. I have an example of that, but I think it might be too detailed and short on time, but essentially about not vouchering things with taxonomic uncertainty and how that ended up pretty poorly for a proponent in terms of further work. But I do have an example here. That's interesting. It's now moving on here, but not up there.
Try the mouse. Try the mouse. Try the left and right keys.
Here we go. I'm not a Mac user. I don't know what's working. So here's an example. This was from the Central Ranges bioregion, which can be seen here surrounded by the blue circles. This is a case where significant flora were not adequately addressed. The survey report listed 32 range extensions, including substantial range extensions from a number of different bioregions. The most surprising of these were Eucalyptus sheathiana and Atrofex semibacata, which, as you can see from a quick look at flora base, are pretty extreme range extensions. They should probably have been written up in Noitsia. However, the specimens were not vouchered. There was no follow-up targeted survey, and the records were not mapped. It is actually, in fact, quite likely that these were mistakes or misidentifications, but it could not be verified. This kind of errors undermine the EPA's confidence in flora identifications for the entire flora and vegetation survey in this project. So, another area for improvement is the floristic analysis, description and mapping. So, where regional mapping is available, it should be used. So, examples of regional scale mapping include Hedl et al. And Mtisby and Hable mapping in the broader Perth-Gill region, Dex, Greenstone and Banded Iron Formation mapping, and the Geraldton and Albany Regional Flora and Vegetation surveys. Pages 34 to 38 of the technical guidance list reports that can be used for contextual reference. However, many of the proposals assessed by the EPA are in areas where there is no established regional scale mapping. So part of the vegetation survey and reporting includes the analysis of quadrat data, definition of vegetation units, and mapping of the vegetation from scratch. The EPA's guidance indicates that floristic composition vegetation classification is the preferred system for a detailed survey. Vegetation description mapping should be an iterative process of floristic analysis and vegetation description that takes place over several seasons. However, in many survey reports, the vegetation is described structurally, and there is no connection between the results of the floristic analyses and the vegetation units that are described and mapped. This is especially the case after only a single phase of survey. There is often little explanation of the discrepancies between the two provided in manual reporting. The issue of conflicting vegetation classification is exacerbated by insufficient quadrats per vegetation unit. 3 quadrats is considered the minimum required for adequate replication of the data analysis. The second phase or year of field survey provides an opportunity to address any gaps in replication after the initial floristic analysis has taken place. There also remains a need for interpretation based on experience and field observations. This simply requires explanation when vegetation descriptions do not align with the floristic analysis. Whether or not you agree with the approach laid out in the guidance, the methodology described there is used by most of the regional surveys and it provides a repeatable and consistent approach for Western Australia. So here's an example of a survey for which the vegetation is not adequate. So the slide shows a map of the study area provided in the survey report. The study area was over 11,000 hectares in size. The colours represent the 13 vegetation units that were defined for the study area. The red squares represent quadrats, and the orange dots are releves, and the green lines are the proposal footprint. The report stated that there were 37 quadrats plus 47 releves conducted for the survey, so that's 37 quadrats over 11,000 hectares. The table in the report summarising vegetation units actually only referred to 34 quadrats. There are only 30 quadrats on that map, including 3. Oh, you can't see it on your copy. There are 3 that are actually outside of the mapped vegetation, and there are only 26 quadrats used in the floristic analysis. So, the mapped vegetation units were determined based on the vegetation structure, dominant species composition and landform, not on the floristic analysis. And although a floristic analysis was completed, which you can see there, it doesn't actually appear to have influenced the definition of the vegetation units in any way, and in fact directly contradicted most of them. There were 2 vegetation units that only had 1 quadrat listed, including the largest one there in purple. EPA As I said, EPA guidance requires replication of quadrats in vegetation units and good coverage over the area, so it's not enough to have 3 quadrats. If it's in this case, that was mapped as over 4,000 hectares, and so they probably should have had more than 1 or maybe 2 quadrats. The result of this was that the EPA had no confidence whatsoever in this vegetation mapping, and they required substantial additional work to be done for the purpose of assessment. So that concludes the technical survey component of my presentation. But before I go, I was going to introduce you to EIA, but we had quite a comprehensive discussion on that with the presenter before me. So briefly, it went live on the 30th of April this year. And the key aspects that are likely to be important for the people in this room from a consultant perspective are that survey reports submitted to support assessments need to be, under the Environmental Protection Act, need to be accompanied by a data package, which includes spatially referenced data from on-ground surveys. The index captures data from those field surveys, consolidates it and provides a platform to make it publicly available. Additionally, IBSA can be searched to discover previous surveys in the area, and in many cases, about a third at the moment I believe, can access the actual reports and raw data for use, depending on the licence conditions that have been applied. So to find out more about IBSA, you can take one of the brochures that I've scattered on tables, or you can go to the website here at the bottom of the page.